In this video, I'm going to talk about the graphs of sine and cosine. So graphing sine and cosine when there's transformations from the parent functions. The rules are going to be the same for sine and cosine with one exception, and we're going to talk about what that exception is. Here is a template I just have sine here, but it's going to be the same thing for cosine, and I'll talk about where it's different. That includes all of the different transformations that we might see for a sine or cosine graph. To start, I have plus or minus in front of the function. If I have plus, then it's just going to look like what the parent function looks like. But if I have a negative in front, a coefficient on the outside that's negative, there's going to be a reflection over the x-axis, or the thing is going to flip upside down. So I just want to talk about what that's going to look like. So if I have positive sine, then I know the shape is it's going to start in the middle. It's going to be an S shape that we start with. And it's going to end in the middle, that shape that repeats over and over. But from the middle, it's going to go up. And that's going to be what the shape looks like from the start for positive sine. So if I have negative sine, then it's going to be flipped upside down. I'm going to start in the middle still, but I'm going to be going downwards. And then I'm going to end at the middle for each repeating cycle. But what the difference is I'm going downwards from the middle instead of upwards from the middle. For positive cosine, it's going to look like the parent function, which means it starts at the maximum. Then it goes to the minimum, then it goes down to the, it goes to the middle, then it goes down to the minimum, then it goes back to the middle, then it goes back up to the top. So it looks like a curve like this, like a C shape. So it starts at the maximum, and then it goes down. So for negative cosine, what's going to happen is it's going to start at the minimum, go to the middle, then to the maximum, then to the middle, then down. So it's going to be just an upside down version of this. And that's important to keep in mind those are the pieces that are going to start the graph. And those things are just going to be repeated over and over. Then another thing that I have, and I want to just lower this so that it's less thick. Another thing that I have is the A in front. This A in front tells me the amplitude of the graph, just like we saw it did in when we were looking at the parent function graphs. So the amplitude is just the positive version of whatever A is. So maybe you see a negative in front. That negative you're just going to consider for if there's a reflection, but the amplitude is just going to be the positive version of whatever's the coefficient in front of sine or cosine. The next thing that I see is this B. This B is going to change the graph, the period of the graph. So the regular period is 2 pi, but to find the new period, we're going to do 2 pi divided by the absolute value of B, whatever that is. Here's an exception. So for sine, a negative B value is going to mean a reflection over the x-axis or the y-axis. They'll look the same. So we'll just call it a reflection over the x-axis. And then for cosine, there's going to be no change. So a negative B is going to mean no change. And this is because sine is odd and cosine is even. So this is because sine is odd and cosine is even. Then another thing that I have is this minus h. When I have that inside, I know that I'm going to have a horizontal shift. So the whole graph is going to shift horizontally. If I'm subtracting a positive number, I'm going to be moving to the right. If I'm subtracting a negative number or adding something to the x, then I'm going to be moving to the left. And then the last thing that I have is the plus k on the outside. So if I add or subtract something on the outside, that's going to tell me a vertical shift. So it's either going to be up or down. If it's positive, it's going to be up. If I'm subtracting a number on the outside, the whole graph is going to be moving down. So that's transformations. Then I want to talk about the steps for graphing a sine or cosine graph with transformations. So the first step is going to be, I'm going to find the period. So I want to find the period and scale the graph. That's going to be number 1. To find the scale, I'm going to divide the period by 4 for the 4 important sections in each period. So to find the scale, I'm going to divide by, divide the period by 4. For the 4 important sections or points in each period. So I'm going to find the period, whatever the period is, and then I'm going to scale the graph based off of that period. I'm going to count by 1/4 of that period, and that's going to be my scale. The second step is to draw new x and y axes based on the horizontal and vertical shift. So the only things that's going to affect the new x and y axes is the horizontal and vertical shift. So the vertical shift and the horizontal shift. After I do that, I'm going to draw the important points. So draw the important points. I have for sine, it's going to be different than cosine. For sine, I'm going to start at the origin. So at the new origin. And then it's an S shape. And then again, for positive, I'm going to be going up and then down. Oops. And then for negative, I'm going to be going down from the start. For cosine, I'm going to start at I'm going to start on the y-axis, up or down, up A or down A, depending on if I'm starting at the maximum or the minimum. And it's going to be a C shape that I see repeating. So for positive cosine, it's going to look like this. And for negative cosine, it's going to look like this, where I'm starting at the minimum. So I'm starting at the maximum, for positive cosine, and I'm starting at the minimum for negative cosine. And then, so just to say this again, I am starting at the new origin for sine, and I'm starting at the y-axis for cosine, either at the maximum or the minimum, which is up or down A. And then the last step is going to be to connect the points in a smooth curve. So connect the points in a smooth curve and make sure to include 2 periods. Include 2 periods. Okay, I'm gonna do one example in this video. Y equals 2 times cosine of x plus 1. One thing that I see is the 2 in front. That is my amplitude, so it tells me my amplitude is 2, which is something I need to include in my graph. Then in front of the x inside of the function, so in front of the x inside of the function, I see a 1. So I know the period is going to be, it's going to be 2 pi divided by the absolute value of 1, which is 1. So it's just going to be like it is in the parent function, which is 2 pi. And then I see a plus 2 on the outside, which means plus 2 on the outside, which means up 2. So I'm going to add 2 to every y value. And it makes, what really I want to consider is that it makes the new x-axis shifted up 2. So I'm going to keep that in mind when I'm drawing my new x-axis. To start, I'm going to scale the graph, so that's going to be my first step. I know the period is 2 pi, so I'm going to count by, so I'm going to count by 2 pi divided by 4, or pi over 2. Which means the first thing on my scale is going to be 1 times pi over 2. The second tally on my scale is going to be 2 times pi over 2, then 3 times pi over 2, then 4 times pi over 2, then 5 times pi over 2, oopsie, and then 6 times pi over 2. I think that's all that's going to fit. So my scale is going to be pi over 2. The next one's going to be 2 times pi over 2, which is pi, then 3 pi over 2, then 4 pi over 2, which is just 2 pi, then 5 pi over 2, then 6 pi over 2, which is just 3 pi. And I put that on my graph. So I'm going to do pi over 2, pi, 3 pi over 2, then 2 pi, then 5 pi over 2, then 3 pi, and then the same in the reverse, but I'm just going to put negative pi over 2, negative pi, negative 2 pi, oh, wait, 3 pi over 2, sorry, 3 pi over 2, negative 2 pi, negative 5 pi over 2, negative 3 pi. Okay, and then before I start graphing anything, I want to take into consideration my horizontal and vertical shifts. I only have a horizontal shift, and so my new x-axis is going to be, sorry, I only have a vertical shift, my bad. A vertical shift. So my new x-axis is going to change from here. It's going to be up 2. So it's going to be at this place here at y equals 2. That's where my new x-axis is. So this is my new x-axis. I've taken care of, with doing that, I took care of this transformation, so I don't need to consider it when I'm doing anything else. Then the next thing I'm going to do is I'm going to look at my model for, this is positive cosine. So my model for positive cosine of x is like this. I'm going to draw this. I'm going to start at my maximum, go down to my middle, then down to the minimum, then up to the middle, then back up to the maximum. So it's going to look like this. That's what the shape looks like, which means I'm going to start at the maximum. So for this graph, I'm going to start at the maximum. The maximum is up to from the new x-axis. So up to right here. And that's going to be at 4, really, for y. And then at the next special place, I'm going to be at the middle, which would mean I'm going to be at the new x-axis. Then at pi, which is the next special place, I'm going to be 2 down from the middle, which is here. And then I'm going to go back to the middle, or the new x-axis there, and then up, and the middle, and down. And this pattern is going to repeat to the left. So it's going to look, oops, I messed up there. This is here, then here, then here. And then I'm going to connect them in a smooth curve. And this is what my graph looks like. Make sure you include the arrows on each end to indicate this graph is going on and on forever.